welcome. In this class I want to talk a bit about how we divide quadrilaterals into different groups, because it is actually rather easy to become confused about this. And the reason why is that you usually have a rather specific image in your head when you think of a shape. For a square, you think of something like this, and for a rectangle, you think of something like this. And these shapes are different. So it is quite easy to think that a square is not a rectangle. But in mathematics, we like to go back to the definition of a shape. What is a rectangle? A rectangle is a 2D shape with 4 sides and 4 right angles. And that is actually true for all of these shapes. So all of these shapes are rectangles, and a square is just a special rectangle where all the sides are equal. So it's a bit like in biology. When we take all the animals, we can make a group, for example, of all mammals. And then some of those mammals will be canines or dogs. And in this system, all dogs are mammals, but not all mammals are dogs. Of course, we can always make more groups. We can make a group of felines, for example, or cats. All cats are mammals too, but cats are never dogs, and dogs are never cats. And of course, if we want, we can make a new group with some dogs and some cats, and some other animals named pets. So some pets will be cats, but not all pets. And some pets are not even mammals. So we can make groups basically as much as we like. So things can get complicated. And you are already quite comfortable with most animals, so you will not easily get confused. But with mathematical shapes, you may have to be a bit more careful. So to make things more interesting, we introduce 2 new types of quadrilaterals. You already know the parallelogram. That is a quadrilateral with 2 pairs of parallel sides. And the definition of a trapezium is that it is a quadrilateral with at least 1 pair of parallel sides. That means that a parallelogram is simply a special type of trapezium. You also know that a rhombus is a special type of parallelogram, where both diagonals are axes of symmetry. We can also imagine shapes where only one diagonal is an axis of symmetry, and those shapes are called kites. A kite is a quadrilateral where at least one diagonal is an axis of symmetry. So again, every rhombus is a kite, because at least one of its diagonals is an axis of symmetry. So let's try to group the quadrilaterals that we know based on what we have seen so far. So we have a lot of different quadrilaterals here. And some of those will have at least 1 pair of parallel sides. And those are called trapeziums. Now, of those trapeziums, some will have a 2nd pair of parallel sides. And those are called parallelograms. So we can see easily here that all parallelograms are trapeziums, but not all trapeziums are also parallelograms. If a parallelogram has equal sides, then we call it a rhombus. So every rhombus is a parallelogram, and every rhombus is also a trapezium. We also see some special shapes here that we have seen before, namely rectangles. Rectangles always have 2 pairs of parallel sides, so they are always parallelograms, but they are special parallelograms with only right angles. And what do we have here, where the rhombus and rectangle groups overlap? Well, these are shapes with 4 equal sides and with only right angles. So those are squares. So this is an overview of most of the quadrilaterals that we know, and this can help you when you wonder how different groups are related. For example, can we answer these questions now? So take a look for yourself first and see if you can answer these based on this overview. So is it true that every rectangle is a trapezium? Well, if we look at this group of rectangles here, we see that every shape in this group is also part of the larger group of parallelograms and also part of the larger group of trapeziums. So yes, every rectangle is a trapezium. Is every trapezium a rectangle? Well, we have a trapezium here, for example, or here, that is not also in the group of rectangles. So we can have a trapezium that is not a rectangle. So this statement is false. Is every square a rhombus? Well, that means if we look at the squares here, are all of these squares also in the group of rhombuses? Well, they are. So every square is indeed a rhombus. Is every square a rectangle? Well, same question, but now are all of these shapes also in this bigger group of rectangles? Yes, so every square is a rectangle. Is every rhombus a rectangle? Well, we can look outside the group of rectangles and still find a rhombus. So this rhombus is not a rectangle, so not every rhombus is a rectangle. Is every rectangle a parallelogram? Well, all of these rectangles are also in this larger group of parallelograms, so yes, every rectangle is a parallelogram. Finally, we were missing one group in this overview so far, the kites, that have at least one diagonal that is an axis of symmetry. Where can we find those? Well, kites are interesting because they don't have to have parallel sides. So like this kite, not all kites are trapeziums. But because they have line symmetry, as soon as we have one pair of parallel sides, we will have two pairs of parallel sides. Now that these sides are parallel, they're also equal. So as soon as we try to turn a kite into a trapezium, it immediately turns into a parallelogram, and it immediately turns into a rhombus as well. So kites are basically spread out over here. They are either among these not very special quadrilaterals, but as soon as we try to turn them into trapeziums, then they become part of this group of very special quadrilaterals named rhombuses. So that concludes our introduction to special quadrilaterals, and now it will be time to start thinking about angles again. See you next time.